Hey everybody, welcome back. My name is Calvin, and today I'll be building a tiny REST API in Java, and I'll verify it at the end in Postman. Let me quickly explain the tools that we'll be using in this video. Java is the language in runtime. I'm going to be using a JDK, or Java Development Kit, that's version 17 or newer. Spring Boot is the framework that makes web servers and APIs simple. It starts a server for me and maps URLs to Java methods. Spring Initializer is a website that generates a ready-to-run Spring Boot project, so I don't have to wire everything by hand. Maven is the build tool that downloads libraries and runs the app. This project comes with a Maven wrapper, so I can run it even if Maven isn't installed globally. Finally, Postman will be the app that I'm going to be using to send HTTP requests. Specifically, our HTTP requests are get to read, post to create, put to update, and delete to remove. To start, I've generated a Spring Boot project from start.spring.io with a Spring Web dependency. We set the groups. The group is default. The group by default is set to com.example. Don't need to change that. And we set the artifact to pizza place. This will automatically populate the name field. We can add an optional description, and we can hit generate. These are the files that we'll use and then will serve as the basis for our API. You also need to download Postman. Postman is a free beginner-friendly app for sending HTTP requests, those being get, post, put, and delete, and viewing JSON responses, and it's easier to use than curl. We can organize our endpoints into collections so you can replay them later. To install Postman, you can go to www.postman.com/downloads and follow the instructions for your specific device. Next, open up your favorite IDE, whether that be VS Code, IntelliJ, or some other IDE, and open up the package that we just downloaded. I'm going to quickly glance at pom.xml to make sure the web starter is present. If it wasn't, I'd add this dependency so the web annotations and JSON mapping work. We can see that this exists in our project, so we're good to go. Now let's get to coding. First, the class that boots the app. This starts Spring and brings up an embedded web server on port 8080. We can navigate to it by following source, main, Java, com, example, and there will be another pizza place folder, and we can find our application starter right here. This should be automatically generated. Now I want to define our data shape. We'll define our data shape in a file called pizza.java. This class is important because it's the JSON shape we'll send and receive. Spring uses a JSON library called Jackson behind the scenes. When a client sends JSON, Jackson will turn it into a pizza object for us. When we return a pizza, Jackson turns it back into JSON. I'll be keeping the fields that I determine in here public so you can see values flow without getters and setters. We'll have an ID field that is assigned by server on create. We'll have a field for the name of our pizza. We'll have a field that determines the size of the pizza. And we'll have a simple Boolean example field. Now that we've defined our data structure, it's time to put together the controller. The API's controller is basically the heart of the application. All the logic and all the functionality is in this controller. I'll start the controller by wiring up the class, imports, and a tiny in-memory list. We'll define our controller class just like we did with pizza.java. We'll add the necessary imports. We'll import the data structures that we need. Specifically, we'll import array list and a Java list. These will function as our simple in-memory databases. Now that we have our dependencies, let's initialize our in-memory storage. Now that we've done the necessary imports, let's mark our controller class so Spring knows that this is the controller. We can do that using these annotations. Now, let's initialize our in-memory database, which is just a simple array list. We'll call this variable menu. We'll also have an ID counter variable, so every pizza that we add into our array list will have a unique ID. We'll call this variable ID counter. Now let's actually move on to building the endpoints. I'll add a route to list everything in our in-memory database. This basically maps get/pizzas to a method that returns list pizza. Spring converts that list to JSON automatically. We'll annotate this. We'll annotate this method so Spring knows that this is a get method. We'll call this method getAll. And this method simply just returns menu. Next, let's add the route to create a new pizza. This time, instead of get mapping, we'll use post mapping because this is a post request. We'll call this method create. In this method specifically, we'll have the @request body parameter. This tells Spring to read the request JSON and fill a pizza object. And this will be a pizza object called incoming. We'll increment the ID. So this will have we'll increment the ID so every pizza will have a unique ID. We'll add it to our array list. And we'll return incoming. Now let's add some more additional functionality. Let's add a route to fetch a single pizza by ID. This will be a get method, so we'll annotate it as such. This will determine a route that is looking for ID at the end. We'll call this method get1. This time we'll have a parameter called path variable. This pulls the number out of the URL. In this case, we're pulling ID from the URL. If I find the corresponding pizza, I return a 200 OK code with the pizza as JSON. If not, I return a 404 not found. So we will iterate through our menu. We'll check for null IDs. If we find it, we're going to return an OK code. And we'll return the pizza object. If we don't find it, we're going to return not found 404. Now let's add the update route. Our put request replaces the fields with whatever the client sends. If the ID exists, I want to update our existing pizza object and return the new state. If it's not found for whatever reason, we return a 404 not found error. We'll annotate our method with a put mapping that's looking for an ID. Call our method update. We'll take in our path variable ID. This time we're also looking for the request body. And we'll call this variable incoming. First, we'll iterate through our pizza menu. We'll check if ID is not null and p.id is equal to ID. If it fits this condition, then we'll update the pizza. Once we're done updating, we'll return a successful code along with the updated pizza object. If the pizza is not found for whatever reason, then we'll return a not found error. Next, let's finally work on our delete route. The purpose of this method is if I remove a pizza, I say 204 no content. If the ID wasn't there, I'm going to return a 404 not found error. So we'll annotate our We'll annotate our method like we did with the others. It's going to be looking for an ID like usual. Call this method delete, looking for a path variable. And this is where we'll return our no content or not found errors. That's all the code for now. Now let's run the app. From the folder that contains pom.xml, I'll run the Maven wrapper. On Mac OS or Linux, I run the following command: /mvnw spring-boot :run. We'll wait for this to build, and at the end, it'll tell us whether it was successful or not. As you can see, we've successfully deployed and initialized our API on port 8080. Now that Spring is started and listening on port 8080, now I'll verify all 4 operations that we put together. First, let's create a request called list pizzas. It's a GET to localhost 8080/pizzas. We run this request, and we should expect an empty list, which you can see that we get right here. Next, let's create a request called create pizza. It's a post to create our new pizza. It'll take in this information and set it in our in-memory database. Our new created pizza has an ID of 1. Let's see if we can get it using the GET request. See, it shows up right here. Now let's create a request called update pizza. It's a put request. In the body, we'll put in the updated pizza details. Now, I create a request called update by ID. It's a put request. It'll take in a request payload of our new pizza details, and it'll update our existing pizza at ID 1 with our new details. You can see that this put request was successful. Running get pizza by ID confirms that we have successfully updated our pizzas. Finally, let's delete this pizza. Let's make a request called delete pizza by ID. We only have 1 pizza in our menu database, so let's put in an ID of 1. Seems like it was successful. And let's see how many pizzas exist in our database now. We should expect an empty array list. There we go. And there you have it. You saw what an API is, how Spring Boot spins up a server, how our pizza class becomes the JSON shape, and how the controller maps get, post, put, and delete to small readable methods. We wrote everything in tiny chunks, then verified the full flow in Postman with URLs so you could see the request go in and clean JSON come back. From here, you can harden it without changing the core idea. Return to a one created on post with a location header, add basic validation and helpful error messages, split logic into a service class, and swap the in-memory list for a real database like H2 or Postgres. If you want discoverability, add OpenAPI/Swagger UI. If you want reliability, write a few tests and containerize it. But even as is, you now have a working mental model, simple data type, small controller methods, clear status codes, and a client to prove it. Thanks for watching, and I'll see you next time.